In this final lecture on determinants, we want to see what Cramer did in the first half of the 1700 years, and in other words, the first half of the 18th century. And the idea is inspired from, so we have A, okay, the matrix A. From the matrix A, we came up with the adjoint of A, which is the transpose of the cofactor matrix. And from there, we came up with A inverse if it does exist, okay, which is 1 over determinant times the adjoint, okay, 1 over determinant times the adjoint, where A inverse is 1 over determinant of A, if it does exist, time Cij transpose. Okay? And what's interesting is he applied this business to solving linear systems where the coefficient matrix is invertible. Coefficient matrix is invertible. So in this case, we know that the linear system has only one solution. So let us, first of all, let's say the coefficient matrix is A. The unknowns are x1, x2, xn. And B, B1 is the non-homogeneous term, B2, Bn. Okay? So the matrix representation of the system is A times X equals B. Okay? So what happened? What is the solution? The unique solution is if you multiply by A inverse from the left, you end up having X equal A inverse times B. So the answer, the only solution to the system, regardless of what B is, it is consistent, and it has only one solution, is A inverse times B. And of course here, if we use the formula we have for A inverse, X will be 1 over determinant of A times the Cij, the coefficient matrix, transpose times B. Okay, so that's the answer. Okay, so let's look at an example. Okay, on a 3 by 3 matrix. Okay, so what do we have? We have x1, x2, x3 equal 1 over determinant of A time, so remember it's C11, C11, so let's put it C11, C12, C13, C21, C22, C23, C31, C32, C33, but we take the transpose times B1, B2, B3. Okay, so if we do the transpose, what do we get? So we get one over determinant of A time C11, C12, C13, C21, C22, C23, C31, C32, C33 times B1, B2, B3. So the answer will be x1, first row, the top of the unknown vector x1, equal 1 over determinant of A time B1, C11 plus B2, C12, C21, sorry, plus B3, C31. Okay, and in fact, what is this? This is just if you take x1 And that was noticed by Cramer. So if you take this determinant now, look what happened. So I'm assuming, sorry, Aij, for A is Aij. So A is Aij. Okay, so here, so if you replace the first column, so by B1, B2, B3, and then you have A1, 2, A1, 3, A2, 2, A2, 3, A3, 2, A3, 3. Okay, so if you replace the first column of the matrix A by B1, B2, B3, the non-homogeneous column, then what you have is B1, C11 plus B2, C22. In other words, the cofactor expansion along the first column. The cofactor expansion of this determinant along the first column gives you what you have there. So, and the same for x2. x2 is going to be 1 over determinant of A. But this time we take the matrix A and we replace the second column. So it's going to be A11, B1, A13, A21, B2, A23, and A31, B3, A33. Okay? So here, and the same for x3, 1 over determinant of A, time A11, A21, A31, A12, A22, A23, B1, B2, B3. So in the second one, we develop it along the determinant along the second column, and the last one along what? The third column. So this gives me what? A way of how to find the unknowns to the system. Okay, if the matrix, the coefficient matrix is, so this in fact generalizes. Okay, so if the more general, okay, if A is n by n, in other words, you have a linear system with n unknowns and n equations, and A inverse exists, okay, then what is xi is going to be 1 over determinant of A, yeah, time the determinant of A1, B, AN. So what you do here, you replace AI by B, the column vector B1, B2, Bn. Okay, that's how you do it to find all the xi. So in fact, how many determinants we need to evaluate here? We need n determinants, because that B will replace each one of them, so it will give you n determinant plus determinant of A. So basically we need to compute n plus 1 determinant. Okay, so let's take an example of this. So let us take the following matrix example. Solve x1 plus 2x3 equals 6, minus 3x1, 4x2, 6x3 equal 30, and minus x1 minus 2x2 plus 3x3 equal 8. So what is the coefficient matrix? So we are going to find 1, 0, 2, minus 3, 4, 6, minus 1, minus 2, and 3. What is the column vector B, the non-homogeneous one? 6, 30, and 8. Okay? So if we compute all the determinants, so first we go for the first determinant, which is A, 1, minus 3. Okay, so we have 1, minus 3, 1, 0, 4, minus 2, 2, 6, 3. Okay, and let us, I'll leave it the details to the people about this, is 44. Okay, that's the determinant of A. Okay, so now what do? We replace the first column of A by the vector B. So we're looking at 6, 30, 8, 0, 4, minus 2, 2, 6, 3. So we replace the first column of A by the vector B, the non-homogeneous B, and we will find minus 40. Okay, so this gives me x1 equal minus 40 over 44, okay, which is minus 10 over 11. The next one is we replace the second column by B. So we have 1, minus 3, minus 1, then the column 6, 30, and 8, then 2, 6, 3. And we compute this determinant, and we will find that is 72. So this gives me x2 equals 72 over 44, or if you want, 18 over 11. Okay? The next one, we replace the third column by the column vector B. 1, minus 3, minus 1, and 0, 4, minus 2, 6, 30, and 8. Okay, and the calculation will give us 152, and therefore x3 is equal to 152 divided by 44. Okay, if you want to cancel by 4, this will give you 38 over 11. So this gives us what? The three unknowns, x1, x2, x3, the unique solution to the system to be minus 10 over 11, 18 over 11, 38 over 11. So before I wrap up this, I want just to make a remark here. Okay. Here, remark. So in the computation of the determinant, okay, we come up with this minus 1 to the power I plus j. And how does it distribute on the matrix? Okay, so if you take any element along the diagonal, it means I equal to j. So it's going to be 2i, it's going to be plus. So in fact, is a plus that you have along what? The diagonals. And after that, it becomes a minus right here. Plus, plus, minus, plus, minus, plus, minus, etc. So here, that's what you get, okay? So this will give you an idea of the distribution of the minus 1 to the power I plus j when you go from the minors to the cofactors, from the minors to the cofactors.